So Al and I were just discussing the fact we had the time change, and it may or may not confuse people, or people may not want to log in anyway. So I guess it doesn't matter.
Just a couple of things going on my side. Or did you want to go first, Jeff?
No, go ahead.
As a reminder, let's see, where's that share button? I have run this Python program that Jeff provided. I've gotten a couple of data points about the steer angle that my device is able to run. I've updated code on my low-level controller. Let's see if I can get back to that quickly. To take those, and I think I put those in the GIST. Yeah, steer motor B3. Which is here. The salient point is those two values, and then they're mapped to the physical angle sensor. And yeah, so the low-level controller is ready, to try to execute that conversion. So I have a startup procedure for actually, trying to run my tractor. I think this is open to everybody who has that link. And because I had to take my electronics box off the tractor and plug everything back in, and it's been a while since I've made all of that work, I'm fighting with getting all this to work again. So this GUI that I wrote, this Python program that uses Tinctor to execute some launch files, it was failing for a couple of reasons. The first one was my IMUs. I have two IMUs at the moment plugged in. So I never really got the USB. I never got, what is it when you have a programmed Symlink setup? What is that?
udev rules. Is that what you're talking about?
I had a udev rule, or I never could get the udev rule set up for these USB for those two things, and so I had some hard coding in there. So I was fighting with that, and I was also fighting with, I have two Ethernet addresses because I had a specific. Well, I mean, there's a wireless chip on the RPi, and then I had the USB antenna Ethernet adapter. And so I was getting a conflict, and I had two IP addresses, and I was fighting with that. So the bottom line is I'm trying to test my low-level controller, and I'm, just fighting getting back to having an operational robot. So at the moment, that's where I'm at, is trying to get my launch files to work and my IMU to work so that I can go out in the yard and do a simple RViz 2D nav goal. But that's where I'm at. My how would I describe my, for some reason, so if I just focus for a second on the IP address issue, for some reason, my Ethernet, my USB Ethernet antenna, I guess I need to figure out what MAC address that is and get the udev rule working on that, or somehow stop the onboard Ethernet thing from trying to also provide an IP address. Because this all was fine when I had my VPN working, and long story short, because my I sort of blew up the Ubiquity, I think my Kinetic 1604 version and my VPN software from a provider called Zero Tier. I don't think they like 1404 anymore, so I'm like lost my Zero Tier VPN. So now I'm down to having I'm going to call it native IP addresses. So I'm just fighting with that at the moment.
So what is the problem with your two networks?
Well, I have to program in my bash RC for my laptop. So I've got a laptop and that I need to call host, or let's just, what do I call it? I have tractor and I have base in my hosts file, and that's in my bash RC. And that IP address is different.
I wasn't aware you had to put IP addresses in that anyway. You just put in that thing's local host and that 11311, whatever that number is. And as long as the two are connected on a network, I think it understands how to make it work. I don't think you have to put an actual IP address in there, a physical IP address.
Well, maybe that would help me then. I don't know if this is gonna, let's see if this is an old version that will open up on this particular machine. So you can so in my bash RC, I have this. So I have tractor AJ and I have controller AJ. And that's what I have in my bash RC. But tractor AJ and controller AJ in my hosts file is defined with an IP address.
You might want to go look at that ROS wiki page that says setting up networking or something and see what they tell you there. Because I'm not sure where it says controller AG, ROS host name. I don't have a file handy here to pull up to see what they look like, but it just seems like, is that controller AG, is that what they call?
Well, that's my laptop. So that's where I would pull up, as an example, RViz and execute a 2D nav goal.
I'm here. Let me go look at the Here's a question for you. If you go to ROS Wiki and do a search, does it work for you? It doesn't work for me anymore. So for instance, I pull up the wiki page and I say search. If I say network and hit enter,
Well, I'm getting a,
it says
security
404 error. But if I go to Google and search, it'll come up. And I don't know if it's because I've turned off all my cookies or because I've configured something else. But anyway, that doesn't work. So let me just do a Google search and say
I'm getting connection is not secure warning. That might, maybe you've got a security issue going on.
maybe. So I just simply went to Google and searched for ROS network, and one of the options is ROS network setup. So let me see what that looks like there.
I get a 404 when I just click in network on search.
And that used to work, and I don't know why it quit working. I thought maybe it's just me that had the problem. So let's see. So if we go down. So I guess what I was trying to think of before, they have something called name resolution. Number 2.0. See, what page are you on here, ROS number? Yeah, okay. So there's a name resolution, and that's where you can instead of having IP address, you can create a name for your various objects. And I tried that once. That seemed to work great, but then I got on somebody else's network, says that's insecure, and it would just turn it off and wouldn't let me run anything. So I quit using that. So I was just looking for some examples there that export ROS host name. So ignore that name resolution for a moment and keep going down to where it talks about here. I look at it on my screen too. So the one down there says, well, it says single machine configuration, local host. I think if you put it at, is it local host you put in using machine name
Yeah.
local?
See, that's what I've done. The issue is my tractor, one time it boots and it goes to the USB add-on antenna and gets one IP address, and the other time it boots and it goes to the onboard Wi-Fi.
You can probably disable your onboard Wi-Fi, and let's see, depending whose software you're running. If you're running the Ubiquity stuff, they may have a configuration to do that. I can't think right offhand. If you're running Raspbian, they have the Raspi config you can pull up and turn things on and off. But yeah, that's a good place to search. So you might just be able to turn that off completely. And if you do that, keep in mind, you make a note of it somewhere so you don't go, oh, my Wi-Fi doesn't work anymore. How do I fix it? Because that's going to happen. So
Yeah, I think that's what I should do. Because that's
but anyway, back to the point. I don't run host names on my stuff, and I don't remember. I thought they're giving me the example here. It says here, put this in, and it'll work, and I don't see that. But I don't recall putting in IP addresses on my machines. So the one that says using machine name local, I can do another way to set ROS host is use local domain. I think I'm doing that 2.4 that says using machine local. And it just uses ubuntu.local, and then you put that port number. And then it's going to be set up a little differently on the master and the slave, but it does that, and it doesn't require the to know your IP address. So up above it says 2.2, it says single machine configuration. Well, yeah, you have to put that in just to get it to run. If you're not connected to another machine, you have to put that in. But then when you got two machines connected, I thought it was a little more explicit here about you know, what it says, type this in one end and type this in the other end, it'll work. And I don't remember now. And I don't have a Linux computer in front of me here, so I can't look up to see how I got my stuff set up.
Yeah. Well, I'll
real-
definitely start with disabling the onboard wireless, and that's probably the fastest path to getting it to simplify.
Yeah, that might get around all the issues of it picking randomly picking one of the others. So
And the udev thing, I'm not remembering why I couldn't get the udev to work on a USB.
I seem to recall that's fairly fairly complicated. You got a million different things you can do, and some work and some don't. So, and that's something else. I've got udev rules for my say IMUs, so I could pull that up and see what they say. But again, I don't have that computer in front of me right now.
Yeah, so
Do you have a copy of your udev rules? We pull them up and look at them.
only if I would have backed up my, this will have been an older copy.
So which one of those would be for an IMU? Or
Here.
let's put which one does not work? We'll put it that way.
Yeah, bear with me a second.
Maybe it's the teensies down at the bottom. I see you have plenty of udev rules.
Yeah, I'm not remembering how all of those got in there.
Oh, this is the stuff it says for platform IO. So it could be this is just to make that work, not necessarily to talk to your machine. Or maybe you started with it, you added your stuff onto it.
Yeah, these definitely.
So those right there, are those the ones? One of those is the ones that don't work.
That would have probably been my attempt. I'm not remembering, Jeff, to be honest.
When I'm thinking the line next down, this is kernel equals TTY ACM asterisk. Depending what type of device, you either have to say TTY ACM or TTY USB. Now, if you're talking to a teensy, those are ACM devices, so that would be correct. And then under things like vendor IDs, there's something they talk about walking the tree of the USB. So you can go out and find out with your device plugged in, you can find the block of stuff that it identified, or just plug in that board and do a D message, which is just a standard Linux command. And it'll say, oh, I just found a new high-speed device. It's of this type. It's got this vendor ID, this serial number. It gives you a bunch of stuff right there in your D message that you can extract pieces out. What you just have to find something that's unique about that board compared to anything else you've got plugged in. So you got to make up these udev rules and just go down the line and say, okay, it's this type of device. It's a TTY ACM asterisk. And then I saw on there you had vendor ID, which for the teensies, that probably works. And then teensy might actually give you a serial number. I don't know if they went to the trouble to do it. The cheap little Chinese boards also all say serial number 1, so you can't use that. And then there's various things on there that you can just pick and choose, but you have to find something that's unique, get enough unique features stuck in so it knows what that board is. And I finally gave up on mine because I'm using the cheap little Chinese boards. So what I did on my the Raspberry Pi, I just did physical addressing. So I say, if you plug it into this particular USB port on the Raspberry Pi, I assign it and say that's that's a IMU, and this next one is, say, a GPS or whatever they are. So I just physically, I got tired of trying to identify them like that, and I just said this port is going to be an IMU, and made up a udev rule that said that.
Yeah, I mean, I have,
Yeah, in fact, right there is where it says devices 1-1.3.1.4. That is identifying a port number on your
Right.
Raspberry Pi. And if you do that, you don't need vendor ID or anything else. You just simply, as long as you always plug it into that port, you're telling it that is going to be whatever that device is. So you decide ahead of time what you want to call that.
yeah, I
And
did
by
that
putting the
for,
vendor ID, that means if you accidentally plug something else in, then it may ignore that, not think it's, say if you plug in an Arduino into that port, like an Arduino Nano, plug it into that port, that would prevent it from saying, oh, that's really a teensy, whatever you got the teensy defined as. So that's one extra little step that possibly helps. So
yeah, I was just looking through this to see if I had added to these notes, fooling around with the IMU, but it doesn't look like I did. Just documented the teensy IDs. But yeah, with the teensies, I was messing around with that physical device. What did you call it? Walk, USB walk or port walk or something.
yeah, they have something that I can't remember what the command is anymore, but you talk to a Linux guy, they say, oh, it's called blah, 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 and I forget what it is. But a quicker way or an easier way is just look at the D-message stuff, and it'll tell you a bunch of stuff about the device you just plugged in. And now in fact, you can extract these numbers out. You can see right there. It's harder to decipher it, but they do, I think, show up when you do that.
Yeah. So that's where I'm at now, is trying to get back to being able to run my startup procedures and have it all run so I can pull up RViz and execute a 2D nav goal and see if it works.
Yeah, and mine is buried right now, so I got to dig it out, and then I ripped some stuff out. I pulled the radio out of it, and I got some of it torn apart, so I got to get mine put back together. If the weather's finally starting to warm up again, I need to be thinking about that at least.
Yeah, and so hopefully the snow's off the ground, and I think it's reasonably dry enough that I can give that a go. That's what's going on in my world.
Well, this week I didn't get much done because I was playing with one of these. It's a software defined radio.
Oh, cool.
You just plug it in a USB port and then load up some fancy software, and it does all kinds of wonderful things. And I fired up and can't really get it to do anything, so I sit there for hours. Sometime in the middle of this week, I was up till 6:30 a.m. just poking at it, trying to find stations to look at. And then finally switched over to YouTube because I have no idea how these things work. And I switched over to YouTube, and the guy with the Swiss accent, if you look at his, he says, how do these things work? And he's got a pretty good description on how they work. And I was amazed that I thought it was something really, really amazing, but it's basically a radio front end. So you got the signal comes into a mixer, and you got a local oscillator, and then they do something called quadrature demodulation. And I'm not quite sure what that is, but that creates an I channel and a Q channel. And then they directly digitize that with an A to D converter and feed it to the computer. And once the computer has it, it can do all kinds of fancy stuff with it and make it work.
I let it lapse, but I previously had a ham radio license. What frequencies does that, what ranges does it pull in?
Well, At first, I thought it was a bigger range than what I'm seeing, but this will go from 23 megahertz up to 1.6 gigahertz.
Hmm.
So you got it. And the trick is it gives you a chunk of the spectrum at a time. So this particular one is you can see 2 megahertz wide on the data you're pulling in. Now, if you pay more money, if you pay, say, $200 to $300 for one of these things, you get one that's 20 megahertz wide. So you can see the entire FM band in front of you. It does a little FFT type display on the screen, and you can see all the little peaks where the stations are. You just click on one, and you got that station starts coming out the speaker. Mine is only, being a cheaper one, it's only 2 megahertz wide, so I can see like four in my area. I can see like 4 FM stations at a time. And then if you want to see something else, you have to painstakingly grab the window and drag it over, and then grab the end of it to slide it over slowly until you get it where you want. And I think if I just run different software, it might be a little easier to play with.
Can you post the link on which model or which manufacturer you bought?
So I just simply went to eBay. At first I went to Amazon looking for them, and I didn't like the pricing they had. So I went to eBay and just scrolled down to found the cheapest ones. And they have ones. I paid like $20 for this. And the guy with the Swiss accent says, if you look around, you can find one for $10. And the interesting thing was, this particular one is not meant to be a software-defined radio. It's whatever that says on there. It's what it says DVB-T plus DAB plus FM. So originally this was made as like a digital television receiver. And he said, some smart guy says he just enabled the debug mode, and then it dumps out your INQ channel directly over your USB. So it's ignoring all the stuff that it was originally meant to do. So it just simply, so the cheap ones, that's the way they work. And then the more expensive ones, I don't know how they do that. So if I dig, I could probably find a link to that. But as I said, I just found the cheapest one that said it was a software-defined radio. And I know nobody wants to hear this, but Alan out in Boston said he just got his AM license, and he says he's broadcasting with a Raspberry Pi, and people in Chicago can hear him, and people in, I think, somewhere in Alabama can hear him. Says if you're bored, you can see if you can pick up my signal. So I thought, well, I know I've got one of those modules I bought years ago, and so I got this big stack of plastic boxes. So I started going through those. At first, I found this other one that's looks like this. This is an actual television receiver. This puts out the, you hook up an antenna on this end, just a regular TV antenna, and plug in USB. And it's got software that's supposed to give you, you say, I want to look at channel 32, and bam, it's supposed to pop up on your screen and show you that. And I don't think I ever got this one to work right either. But I found that one first. I found its antenna like this. So that's the antenna that came with it. And I kept digging through the box, and I found the module. So I found this much of it. And I kept digging. I got all the way to the bottom of the boxes, and I thought, well, I don't have an antenna for it. It's got a stupid connector on it. And so I thought, okay, fine. I'm not going to waste 2 weeks looking for this stuff. So I was upstairs in front of my computer. I thought, okay, well, let me check on Amazon and eBay. And I found one that was for $20. So I said, click on it. Said, okay, send me one of these. So it's supposed to show up Saturday in the mail. So in like 2 days, it'll show up. So I went down and put my boxes away, and either right on top or a couple boxes down, there was the antenna for it. So now I had a complete setup. So I sat on that for a couple of days and finally plugged the module in. I see Linux did recognize it. And I just went to the Ubuntu software store and said software defined radio. And it says, oh, here's this, it's called GQRX or something. And I said, okay, load that. It took forever. It took like 5 minutes or 10 minutes to load all the crap. And I fired it up, and there's another step in there. I won't tell you that my problems were, but basically at that point I could then do the stuff where I could see the spectrum and then click on things and pick the modulation, demodulation technique and whatever. So it turns out this one doesn't go low enough in frequency because the guy in Boston is transmitting at 14 point something megahertz, and this one only goes down to 23 megahertz. So your options are you can either buy an up converter or build an up converter that takes the lower stuff and slides it up where you can see it. Or if you have I think you buy the one from stl-sdr.com, I think and maybe you have to be running the right software. A guy says, oh, here's how you get the AM band and the high frequency band in the ham radio. You just go into this menu and you say set to just decoding the I and Q channels and pick the Q channel only. And then he says, here's this other number. It was set to this default at 2.048 megahertz. He didn't know why, but he put that. And sure enough, he popped it up and he was getting just tons of all the ham radio stuff and everything was coming through. So there's another way to do it, but I couldn't find on my menu a way to do that. So I don't know if it's just that I'm running the wrong software or they got a different chipset in that thing. So anyway, that was, I wasted most of the week playing with that and didn't get a lot done. Oh, and that and digging my ditch out back, trying to keep my water flowing so it doesn't come in my basement.
And the guy in Boston, you know him or you just know of him?
I know him. He's the guy that started Twin City Robotics like 20, 30 years ago with two or three other guys from Cray Research. They started that. And then somewhere along, like 5 years ago or 6 years ago, they moved out to Boston because his wife's from out of that area. So he's living out there now. And the story was that his wife went to a wake or a funeral or something and spent like a week in close confinement with all these other people inside of a house. So when she came back, he said, well, we have to quarantine. So he locked himself in there, like the den or whatever they call it out there in that part of the country. And he says, well, he doesn't have anything to do for a week. So what he did was he said, I might as well study for my ham license. So he read up on it. And then like a week later, he took the first two tests to become a ham radio guy. And he said after about a month, he took the next test and he got his whatever the license is where they give you the call sign. So just within a month or month and a half, he went through and became a ham radio guy. And then since he was that he looked at this thing. It turns out you could take a Raspberry Pi and load special software, and it wiggles an output pin at whatever frequency you tell it. And you're supposed to put a low pass filter on, because if you don't, the square wave coming out of the thing, blasts all over the entire spectrum. So you put this low pass filter, and just the Raspberry Pi and the low pass filter and a piece of wire, you can transmit with this thing. And he was just that he was able to transmit from Boston to Chicago. Somebody was hearing him there. They have the software called WSPR, which is weak signal propagation something reporter. And the thing is, it's meant for testing your antenna. So you can say, you put an antenna on your radio here and you transmit, and then you've got this automated software running on somebody else's computer. They're watching the radio and it decodes this stuff. It's like 151 bits over 2 minutes. And it propagates. So coming off his Raspberry Pi is something like 30 milliwatts or something power coming off this pin. And somebody in Chicago could hear him and somebody in Alabama could hear him. And then it automatically decodes your call sign, and you tell it the stuff you're sending. You say, this is how much power I'm putting into my antenna. And you tell it, I think, your location. And then that automatically shows up. And I might be able to quickly find something here to show you what that looks like.
Yeah,
none of this has anything to do with robotics, but this is what I was doing. So
yeah, there's a massive, if you're doing a Venn diagram, I think there's a massive overlay of ham guys and robotics guys.
Yeah, it seems like any kind of electronics, and then the ham radio stuff seems to go together. So if you go to YouTube and look for, here, let me try that once.
Yeah, I remember this as WhisperNet.
Yeah, that's what it is. And it's set up the point where basically so I was thinking, well, I don't need to see if I can hear him, because you pull up, there's other people in Minneapolis running the software. So if they can hear him, it will log that. So.
But I have never heard anybody using an RPi as a ham radio.
You just look up Raspberry Pi transmitter, and that, because the other thing, because once you have the software defined radio, you can get these different plugins to do different things. So you get one plugin that'll read your power meters on the side of your house, or you get one that reads your little key fobs for your car. So I've got, so I've got one of these, and you can get a plugin that will read those. So basically it says, here's the frequencies, and then knows how to decode it. And then they were saying, once you do that, you can then use a Raspberry Pi to transmit. So you take the codes from here and transmit the Raspberry Pi to unlock your car. So you want to steal people's cars, you could do that. You could just wait till they hit the button and record it, and when they walk away, you play it back with your Raspberry Pi, and you can unlock their car. So that's which actually mine's got 2 buttons. So I guess you have to wait for them to actually unlock the car, and then go follow them around to the next store. And when they get out of the car, then you can unlock it. Otherwise, if they hit the lock button, all you can do is lock their car. So anyway, there's that stuff. You can pick up the NOAA satellites, the weather satellites. So you can generate pictures coming off those, or you can talk to the ISS, puts out some kind of transmission. So anyway, once you look into the stuff, there's just thousands of things you can do with this radio if you're so inclined to do that. And I was going to try to decode my module for my car, but I went to that page and said, oh, first you got to load the Go language. So here's yet another thing to distract me. They wanted me to load up the programming software from Google in order to make the thing work. And if I would just spent the time, it probably would have worked and everything would be happy. But yeah, if you type in that whisper WSPR on YouTube, it brings up all kinds of stuff. And in fact, here's trying to just find a picture here that would show me. So let me just see if I can find a picture here, because there's a well-known picture. It shows a map of the world that shows your transmit location, and then all the people you can hear. And now, of course, there's one. So here, in this picture right here, the person right here is the person transmitting, and then all these people around the world can hear them, and so it automatically picks this up and decodes it, and then puts it out to a website saying, I found this data. So if you start transmitting, you go to the website and say, show me people that can hear me, and it draws up this map for you. So that's something else. If you're so inclined, that's more stuff you can play with. And at the moment, I'm not that interested in doing that stuff since I don't have a ham license. I can't transmit, and there's probably other stuff I'd rather listen to than somebody's test signals. So
I couldn't see what frequency they were transmitting on.
Oh, let me. If you pull up the report here, here we go.
Because it sounds like he went through actually 2, maybe 3 layers of licensing. If he sat for 3 exams.
Yes. And again, being an electronics and software guy, he just said, okay, I'll just read up on it and go take the test. And I've heard of people doing that before. I've never attempted. I just never had the ambition. I don't. Anyway, there's again hundreds or thousands of videos out there talking about SDR and talking about this whisper and talking about all the plugins you can do to make it do wonderful stuff. And the guy with the Swiss accent, if you go to his stuff and type in SDR, he's got a good description on how the things work and why they work, and lists a bunch of stuff you can do with them. So.
And what was he doing with it?
He's one of these guys. He just tests everything out and tells you how it works. So it's hard telling what he was actually doing with it. He was talking about something he was doing. He was transmitting something and then, driving, see how far he could drive and still pick it up or whatever. So that's probably what he's doing. But he was just saying what they are and how amazing they are. So if you buy the really cheap ones, you get the bandwidth of 23 megahertz to like 1.6 gigahertz. If you pay like $300 for it, you get ones that go all the way down to from like 100 kHz up to 6 gigahertz. But they want a lot of money for those. And some of them will also transmit too. You can say put it in transmit mode. But again, if you don't have a license, you're not supposed to do that. So I'm better off getting one that doesn't transmit. Oh, and then the other thing was, I needed some other source. I pulled out my radio control here that's got the LoRa stuff in, set my SDR to 915 megahertz. And if you just go to 915 megahertz and watch it for a while, you can see these things, those things pop in and out where other like control signals from around, I don't know how far away they are, because the little antenna is just like a little 5-inch whip antenna that comes with it. And everybody says, oh, you got to put a big wire outside for an antenna. But you can see these things popping in and out. And I don't know what to do with them. So I turn on my thing, and boom, I got this giant signal shows up. And it shows up in multiple places. So I don't know if it's blasting somewhere it's not supposed to. I haven't tried turning it on and leaving it, say, in one side of my house and turn on the receiver somewhere else to see what it does. But I can indeed see that on it. And probably I could get a plugin that would say decode the LoRa stuff, and that may be useful information, but I haven't looked into that. I just always get frustrated because I can only find the FM band, and up at like 164 point something megahertz, Minnesota has a weather channel they broadcast on. And I all the way down to like 27.3, I found a channel that sounded like NPR or a British station just talking about the world politics or something. That's really all I can find over the entire band of just poking around. So I always get discouraged when I play with that.
And your pal in Boston, is he broadcasting his audio, or is he doing
No, it's the Whisper network is what he's running. So he's just got custom software that says you tell it where you are, you tell it what your transmit power is, you tell what your call sign is, and a few other things, and it just broadcasts that data out. So it puts out a packet that puts that out, and if somebody else picks that up running the software, that it decodes all that and it writes it to a web page, say I can hear this at this time.
oh, so that's literally all he's transmitting?
Yes.
He's not, I mean, because you can
if you get the right software, you can make these things transmit anything you want, apparently. Because as I say, there was a thing that said it'll unlock your car by, you have to get the right software and then feed in this code, and then it'll transmit the data and unlock your car. So, basically it will transmit on, and I don't know what the different frequencies are, what its frequency range is, but that's something else you can look up if you've got an interest in doing that.
Yeah, when I happened to live in London for a while, and I was a part of a radio club there, and one of the guys was enamored with doing what they referred to as a moon bounce. And they literally took a Yagi antenna and pointed it at the moon and transmitted up, bounced a signal off the moon, and came back and proved that, it was like a 1200 baud bandwidth text signal that they could get up and back. And it was like, was it 2 seconds up and 2 seconds back, or like 2 seconds round trip up? What I mean, is this the speed of light? It was just fascinating. It was just super, super cool. I mean, it was just, somebody asked, well, what's the use of this? I'm like, it's just a hobby.
Yeah. Yeah, I learned all about the delay when Apollo went to the moon. So that, they say something, you got to wait so much time before they respond back. And I couldn't remember if it's 2 seconds or 3 minutes or what it was, but it was, I think it was in the matter of seconds.
I mean, he was basically, he was at the time was like I don't know whether it was, I forget his radio brand. I mean, it was a regular ham radio with a nice Yagi antenna, and he had a nice gear, but it was pretty interesting. But I remember it was 12, they calculated it was like 1200 baud went back, and like no low bandwidth, but he got up there and back.
Yeah. So,
Very interesting stuff. But
so, so
I'd never heard anybody turn a Raspberry Pi into a transceiver.
well, that's now what's the Raspberry Pi showed up. They got all kinds of new applications for all this stuff. So it's all, all fairly new stuff that they're figuring out to do with this.
Very cool.
So back to robotic stuff. I fired up my that little Gazebo simulator that's got the 4-wheel vehicle in, and I see it's not publishing any type of odometry data. So I thought, well, how can I do that? I looked at the code that's what they call the Ackerman controller, which is a Python script. You put in the Ackerman command message, and it generates the speeds and the steering to feed to Gazebo to make your thing drive around. And I looked for that, and some on the construct, somebody had asked the question, how do I get odometry out of Gazebo? And he pointed out if you do, there's a ROS service in Gazebo that will tell you various things. And I normally don't use services, so I didn't even think of that. It also, Gazebo publishes like Gazebo joint states, Gazebo link states, and I think it also has one just called /joint states. So it's publishing lots of data. And the thing on the construct says, look at your ROS services and find the one called Gazebo joint state. And he said, so you do a call to that, and it comes back and gives you a pose and a twist message of where your vehicle is. And he was saying, you can do, if you don't have real odometry, you can do that. So basically, it would be like on the stage simulator where it says, okay, I know where you are. Let's convert that into something and just publish that and say that's odometry. So that's one way to do it. And the other way to do it is to figure out which one of those messages you're telling you the actual, as the wheels are turning, read the actual position of the wheels and do your odometry calculations and create an odometry message from that. So that's a couple ways to approach that. So that's one of the things. I was just looking at that last night. And the thing on the construct, he goes through, it's one of those half-hour things where he says, type this in, do this, create this package, do this, do this. And I thought, well, can I just find it where it's all typed in so I don't have to retype all this stuff? But I didn't find that. So one way would be start with they have a tutorial says, how do you publish odometry? So start with that one and then rip out the fake code they've got in there and then say, okay, now read the stuff from Gazebo, strip off the fields and take the fields from there and plug them into the other message. And that would be one way to do it without having to retype everything. But I was just hoping he was going to say, oh, here, go look at this page here, and here's all the stuff typed in there, but I didn't find that. So anyway, that's one of the next things I would have to do to make this thing, look like a real vehicle is get odometry information out. And then they've got actual plugins for, say, GPS and IMU and sonar and camera and depth cameras. Those are actual Gazebo plugins you can just drop in there and it will start publishing that stuff. And I know that works, so I haven't played with any of that yet. So that'd be another thing, once it's moving, then put that kind of stuff in and say, pick something that's equivalent to what I already have for sensors and say, make it start publishing that kind of data.
What was curious to me is you said they weren't publishing command velocity data.
Well, it's the fact that they aren't publishing anything. They are subscribing to Ackerman message, or you could subscribe to command velocity, but since they want the steering angle anyway, that's just the way this guy wrote the code. He picked Ackerman command as opposed to command velocity. And the only person publishing anything is me. I just have the command line publisher, ROS publisher that says I can either publish command velocity or I can publish Ackerman message, but there's no sense publishing command velocity because nobody's listening to it right now. But I can always grab that translator out of the tab planner plugin, and somebody ripped the code out of the tab planner, made a standalone module that will subscribe to command velocity and publish Ackerman commands. So I could use that as a translator to, then it run with any of the planners out there, just the stock move base and the stock whatever the local planner is called in that. So that's something I've been meaning to do, but I haven't done that yet.
So in your understanding, an Ackerman command angular Z is effectively the same thing as a command velocity angular Z.
Ackerman message has nothing to do with rotational velocity. They blatantly publish steering angle, the steering speed, which is how fast you want to change that angle, and I think a third field on that. And then for the speed, they've got velocity and acceleration, and then jerk, which is the change of velocity. So that it's got slightly different fields, and they don't. So Ackerman message never deals with rotational velocity at all.
Hmm. So it's just a completely different construct.
Yeah, but if you think about the fact it's just like the modified command velocity the TEB planner puts out, where they say here's the forward velocity and the steering angle. That's what, if you expand that out, put the extra fields on that, that's what the Ackerman message is.
Hmm.
So it's just all a matter of the software you're writing. What does it want in? What do you want in steering angle, or do you want rotational velocity coming into it? And then based on that, you can pick either. If you want rotational velocity, you'd pick a standard command velocity. If you want a steering angle, you can use that modified command velocity, where they just blatantly overwrite the rotational velocity with a steering angle. Or you could go to Ackerman message, which is just a different format for doing the same stuff. And it just has velocity and steering angle with some extra stuff put on there.
I don't think I understand all that, but I will rewatch this and maybe it'll sink in. Well, you're definitely making progress on using Gazebo.
I'm not making a lot of progress because I mainly sit around doing nothing. But yeah, if I would just work on it, I could make some progress and get that to the point where it's at least usable for me. And that if I because that video I posted last time, yeah, it was the meeting 2 weeks ago, and I was saying here was my thoughts on how you understand this stuff. I found several videos on YouTube and said, okay, start with this one. He basically says this is what URDF is and how you build a little model of an arm that slides back and forth on a plate, just as an example of how to do stuff. And then he went to the next one. He says, here's how you build a differential drive robot, and he's building this stuff from scratch. So he said, okay, create this cylinder and flip the cylinder up on the side, and that's going to become a wheel. And then you put a joint on so it'll rotate. And I just went through and did that. And then I said, okay, now how do I convert that into my four-wheel drive one? So basically the back wheels work like the differential drive, where you just define two back wheels with rotary joints and stick them right on the chassis. And for the front, I started off, I just did that, duplicated that. So I had two wheels in the front with rotary joints. So it would have been like tank steering or like a Bobcat steering, some kind of skid steer at that point. And then once I got that, so it would drive forward and backward, then I added the steering joints in between the frame and the front steering wheels. And then I could turn those. And then I just had to get all the names to match. And then I could use that guy's script that generates all the joint states, which are, basically tells how fast you want the wheels to turn. So it generates all four wheel velocities. And then it takes in the steering angle and then figures out what angle to turn the left wheel, the steering of it turns the left wheel and the right wheel. He does the calculations to do that. So I said that was a good way for me. That was a good way to do it, by looking at that first video that says here's what URDF is, so you understand how you build models to talk to Gazebo. The second one says here's how you build an actual very simple robot that will drive around. And then the next thing on the video, then there's things, if you go to the ROS has tutorials. One of them is from the ROS 2 stuff under the navigation 2. There's one that says setting up your URDF or something like that. And then they jump right into the macros where it says define tire diameter, define the wheelbase and all this stuff. You put that in, and then down in the code, the code does macro expansion. So you basically stick those in as variables and say, I want to create 4 wheels. And if they're all the same diameter, then you just have a wheel macro, and you pass in the variable up above, says here's the diameter, and you just instantiate 4 of those wheels and tell it where to put it on the vehicle. And it turns out that the stuff I started with, that little radio control car model, it was to me, it was extremely complicated, and I couldn't figure out his terminology. He kept talking about it was terminology based on his radio controlled car. So he's talking about his hex hubs and his U joints and his axle length and all this stuff. And I had no idea what the car actually looks like. And I was trying to rip that stuff out just to make it work more like, say, a tractor or a lawn tractor. And he had shock absorbers on. It took me forever to figure out how to get rid of those. So I got it all done. I had to run it through that macro expansion that gave me the flat file. So I, instead of having a thing that says generate a wheel, now down in the code it says generate the left rear wheel, and here's all the parameters that go with that to generate that. Then below that was a thing that says generate the left right wheel and all the parameters, and I could change them one number at a time to see what that would do. Because again, I had no idea what hex hub was, had no idea what his U joints were, or all this other crap. I had no idea what any of that was. And then by the time it went through this macro, I couldn't tell at all what he was doing. So now the point is, what I followed through the 3 steps that I said. You take the introductory to URDF, you take the 2-wheel drive differential robot, and then you go to the one that's on the ROS tutorial. And the ROS tutorial introduces that concept of defining the parameters. I think they call it properties, the properties up front. So it says, here's your wheel diameter, here's your wheel width, and then this thing that says here's your chassis width, and all that kind of stuff. And then I thought, okay, I need to put that kind of stuff into mine. And then by the time I looked at that, I realized, the stuff I would need to do is what he did in the radio control car one. So now I think I know enough about how I could go back and either modify that one or just change my new code to look like that. So I've got a path in mind. I just, again, been too lazy to actually do it.
Have you shared any of that any place?
No, other than just having the picture of it driving around. And I think what I need to do is say, look at the guy's 2D car model and then say, here's, and that's got his URDF stuff on there showing, the complete thing to do that. And then say, okay, I just took that and made it into four wheel one. So here's basically the flat model with my 4-wheel vehicle that drives around. And then say, okay, now here's the third one where I've now put the macros in there to, so it automatically builds this stuff for me, publish like 3 different things there and say that's, and that way it's good. You can see each step, why does it do that? And because if you start with one that's built on the macros and has all this stuff crammed together, to me, it's impossible to figure that out unless what the guy was talking about to begin with. So that it seems like that would be a good way to do that. But my main objective is make sure I get the water drain behind my house. So I'm going to, play with that the next couple of days, and hopefully that'll get rid of most of it. So then I can get back to doing something.
Well, good luck with, you can turn off recording now, I think.
Okay. Stop recording. Stop.